Alright guys, and welcome to this quick video showing you how to use the GeoGebra games found in the 5th chapter of our curriculum. So here I am in our haiku site. Yes, I am on my computer doing this on the internet, but note that this will be almost exactly the same looking on your iPad, and anything that I'm doing here on the computer will look the same on your iPad. So our first game, and note to self, I always suggest viewing it in a pop-up, especially on the iPad, because it'll make it larger and you can kind of see what's going on. So in this game, what we're going to do is we're going to be given a randomly generated equation, in this case y equals x minus 2. And what we need to do is we need to drag these blue dots in such a way that we make this black line match up with this blue equation. One thing I will note is that we usually write our linear equations slightly differently. For instance, I would have written this as y equals negative 2 plus 1x. But alas, this program is such that it always gives our equation in this form. So be really careful about determining what is our slope and what is our y-intercept when you're dealing with these equations. So when I look at this, I think our y-intercept is negative 2. So there's negative 2, our y-intercept, and I think our slope is positive 1. So I'm going to drag this second dot, this point rather, to make our slope positive 1. And oh, check it out. The moment your graph matches this equation, it turns green. You get a nice little congratulations, and you have the option of getting a new randomly generated equation, and this line kind of resets. So I think this one has a y-intercept of 2, a slope of negative 5. So for a 1 unit increase in x, we will have a 1, 2, 3, 4, 5 unit decrease in y. We did it, hurrah! And we can continue as long as we'd like. And you can do this by yourself just to practice, or you can compete against someone else, in which you can say, who can be the first one to get to a score of 5 or 10 or 20 or what have you? Or who can get the highest score in a set amount of time? Maybe 1 minute, 2 minutes, 5 minutes, what have you. Okay, let's take a look at these other games. Okay, so the second game we've got here is slightly different. In this one, in the first game, we were given an equation and we kind of had to draw its graph. Here we're given a graph and we need to draw its equation, or rather come up with its equation, excuse me. So I'm looking at this graph and I definitely see a y-intercept of 3. And I am going to count it out, and it appears that this line has a slope of positive 1, 2, 3. For a 1 unit increase in x, we have a 1, 2, 3 unit increase in y. So coincidentally, the y-intercept and the slope happen to be the same. Okay, big deal, big deal. This is totally the correct equation for this graph. But if I were to click check your answer, it's going to think I made a mistake. Why? Because this program, for some reason, does not like its linear equations in this form. It wants it to be 3x plus 3. Alas. So what I do is I type it in the way I like it, and then I press enter. It changes it. It keeps the exact same equation, but it turns it into a form it likes, and then I check our answer. Oh, check it out. Thumbs up. Hurrah. Our score is 1 of 1, 100%. That's pretty sweet. Let's get a new randomly generated line. I think the equation of this line is y equals 4 plus 1x. Remember, I'm going to press enter, and then it changes it to the way it likes. I'm going to check my answer. Hurrah. Now, let's see what happens if I don't press enter. So y equals 4, coincidentally again, and I think the slope is positive 3. So 4 plus 3x. Oh, it's interesting. Oh, even if I just click away from this box, it will rearrange it and everything's groovy. But if, for instance, y equals 0 plus 1x, if I click check my answer now, I think I'm going to get a thumbs up, but it's not going to count it towards my total. Yeah, see, it's like, you're right, but it didn't count it towards your score. So just a note, always either click away from this box or press enter before checking your answer. Okay, the next two games are exactly the same as the first two, except they involve slopes that can be fractions as well. So it's absolutely no different. This first one is, here's an equation and you need to graph its graph. And this one happens to have a integer slope, but they're not always going to have integer slopes. For instance, there we go, y equals 1/6 x plus 2, or as I prefer to say it, y equals 2 plus 1/6 x. So I think we have a, oh, that was completely random that this point happened to be in the right spot already. Let's do another one. Okay, y equals negative 5 6x plus 2. I would call this y equals 2 minus 5 6x. So 2 for a 6-unit increase in x. 3, 4, 5, 6. We should experience a 5-unit decrease in y. Ba-boom. Ba-boom. Fantastic. And we can continue. And similarly, the fourth game is the same as the second, where you are given a line and you have to find its equation. I created this one. The one I used before was one that someone else had created. And here, let's see, so let's try and find the equation for this line. So let's see, I think it has a y-intercept of 4, and the slope looks to be like negative 1/2. And what's nice is that even though we probably should have some parentheses or something in here, it will actually interpret it, this equation for us very well. And here, there is no button to press to check. You just press enter and boom, your slope is correct, your y-intercept is correct, you're correct, hurrah! New random blue line, amazing. Now if you were to make a mistake, so for instance, I think that the equation of this line in blue is y equals 3 minus 1x. But if you made a mistake and said y equals 3 plus 1x, let's see what happens. What the program will do is it will graph in black the equation that you put in order to say your y-intercept is correct, but your slope is not. And then you can readjust and say, oh, of course the slope is negative 1. Oh, come on, Benji, you're better than this. Phenomenal. And if you're totally wrong, right, if I said that the equation of this was y equals, 5 minus 2x, it's like, yeah, well, that's the graph of what you said. The slope's not right, the intercept's not right, you're just, no, I'm sorry, I don't know what to tell you. So negative 2 plus 1/2 x, boom. Ooh. 1/2 x. There we go. Phenomenal. And I should have put a y equals, but I guess it could interpret it without it. But you should put a y equals there. Okay, last one is graphing lines in standard form. And all this is once again, you are given a graph, you are given an equation, and we need to go ahead and graph that equation by dragging these points all over the place. So for instance, I'm not sure why this is showing up in this game, but alas. So here I think if we were to rearrange this, we'd have y equals negative 3 minus 2x, y equals negative 3 minus 2x. Phenomenal. All right, so let's click new line. We'll get a new randomly generated 9 for us to graph. Now, whoa! 4x plus 3y equals negative 9, that's a little tougher to do. I don't think I'm going to be able to graph that without doing a little bit of work on some scrap paper. So let's go ahead and let's do some work on some scrap paper. So here we go. Let's see, let's subtract 4x from both sides. We end up with 3y equals negative 9 minus 4x. We'll divide both sides of this equation by 3. Yielding our final equation, y equals negative 3 minus 4/3 x. So hopefully we can just remember this moving on. So our y-intercept is negative 3, our slope is negative 4/3. So our y-intercept is negative 3, our slope is negative 4/3. So for a 3-unit increase in x, we should have a 1, 2, 3, 4-unit decrease in y. Hurrah, correct, life is good, new line. Another option you might have is to use the intercept method. Unlike in this equation, I think the x-intercept, if we set y equal to 0, is 16. Boom, our x-intercept is 16. There she goes. Our y-intercept, if x are equal to 0, would be negative 4. And boom. You could, of course, put this in a slope-intercept form, but another way to graph it. And again, you could do this on your own, or you could compete. So again, happy gaming.